In this video, we have been given that a to the power of x equals to natural log of x, and we shall have to find the values of x. Now, how can you solve such an equation? The equation is e to the power of x equaling to natural log of x. Now, first of all, let's introduce base e on both sides. So we shall have e to the power of e to the power of x equaling to e to the power of natural log of x. And if you recall, whenever you have, let's say, e raised to the power of natural log of a, this will be equal to a. Therefore, in this case, e to the power of natural log of x will be equal to x. So we shall have e to the power of e to the power of x equaling to x. Now, what should we do at this point? You check out this. If we multiply both sides by e to the power of x, on the left hand side we shall have e to the power of x times e to the power of e to the power of x, and this will be equal to x times e to the power of x. So this will give us e to the power of x times e to the power of e to the power of x equaling to x times e to the power of x. And at this point, if you look closely, you will notice that we can apply the Lambert W function. Whenever you have, let's say, a times e to the power of a, if you apply the Lambert W function, it will give you a. So in this case, if you look at the left hand side, here we have e to the power of x, and also we have e to the power of x as the exponent. And also on the right hand side, we have x here, and also we have x as the exponent. This means that we can apply the Lambert W function. So we shall introduce w on both sides. On the left hand side, we shall remain with e to the power of x, and then on the right hand side, we shall remain with x. And once again, we shall apply the Lambert W function. But in order to do that, first of all, let's divide both sides by e to the power of x. This will cancel with that, and we shall remain with 1. Therefore, we shall have 1 equaling to x divided by e to the power of x. And at this point, we can take e to the power of x to the top, and the exponent will become negative. So we shall have 1 equaling to x times e to the power of negative x. Now at this point, in order to apply the Lambert W function, there is only one thing missing. If you look at the right hand side, this x is positive, but this x is negative. So what we shall do, we shall introduce a negative on both sides. So we shall have negative 1 equaling to negative x times e to the power of negative x. And now, as you can see, this is the same as this. Therefore, we can apply the Lambert W function. So on the left hand side, we shall have w into negative 1 equaling to w into negative x times e to the power of negative x. So we shall have w into negative 1 equaling to negative x. And if we divide both sides by negative 1 by negative 1, this negative will cancel with that. And so we shall have x equaling to negative w into negative 1. Now at this point, it looks like we shall get one value of x, but actually we shall get more than one complex value of x. This is because we can take different branches of the Lambert W function. Therefore, the best way to write this will be x equaling to negative w into negative 1, and then we shall put n here. So if we take 0 as our principal branch, this will be equal to 0. And if you put this in an online calculator, you'll get x approximately 0.318 minus 1.34 times I. So it's a complex solution. You can get this by putting the function in an online calculator such as Wolfram Alpha. You will write it as negative w into 0, negative 1, and it will give you the same answer. Therefore, that's how you can solve such an equation. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.